Average rates of change. Average rates of change is a major lesson in AP Precalculus. For instance, let's say I'm asked to find the average rate of change between point A and B. Well, the way that I would do that is I would connect a straight line between those 2 points, and I calculate the slope of that line. This line right here is called a secant line. So, the average rate of change is the slope of a secant line connecting 2 points on a function in interval a through b. You can also use the formula you learned in Algebra 1 to calculate the slope of that line. You can use the fancy Precalculus version up here, or the one you learned in Algebra 1, or you just memorize these phrases, right? There's multiple ways of saying the formula. So the average rate of change is basically the ratio of change in the dependent variable over the change in the independent variable. Or in other words, it's the ratio of change in y over the change in x. Sometimes you'll see that as delta y over delta x. Okay, change in y over change in x, which is basically this formula right here. Or it's the change in output over the change in input. That one's the easiest to memorize. Change in output divided by change in input. Okay, let's do an example. Our first example is a physics example. It's some sort of projectile being launched from a chair or a stool. The first thing I'm going to do is make sure I keep clear in my head that the x-axis in this example is time and my y-axis is how high something is. So I'm going to keep that straight in my head. And also that time is my input, height is my output, this is my independent variable, this is my dependent variable. And that helps me figure out. So it's asked me to calculate the average rate of change on the following intervals. And it says calculate the average rate of change on the interval from 0 to 0.25. Now this obviously is communicating to me the x values. So it wants me to calculate the average rate of change in the first quarter second. Well, my projectile's first output is 2. And its final output is 5. So how much of a change is that? Well, my change in y would be therefore 5 minus 2. That's what would calculate how much my y changed. And that would give me a 3 feet. How much did my input change? Well, they kind of already gave it to me with the numbers here. But as you can see here, from here to here, my input changed by 0.25. So my new time was 0.25, my old time was 0, and therefore my change is 0.25 seconds. And 3 divided by 0.25, you can type that into a calculator if you need to. It's 12 feet per second. Another way you could have calculated that was just by looking at the graph here and figuring out that this is an increase of 0.25. And that is an increase of 3. So it's positive 3 divided by 0.25. I can divide those numbers and get the answer. On the next interval, it wants me to calculate the average rate of change here. So I can use that technique again. I'm going up by 1, across by 0.25. Let's write that methodically so that I don't make a mistake. So I'm going to do a change in y. Yeah, it's a lot to write. And a change in x. Okay? Set yourself up for success. To find something's change, you are subtracting something. And when you set yourself up for success, you won't make mistakes with negative values or the like. Okay. The change in y for this part is from 5 to 6. So from 5 to 6. And the change in the x value over here was from 0.25 to 0.5. Okay? So the change was positive 1 feet, also in 0.25 seconds. And you type that in a calculator, and we're going to get 4 feet per second. So the average rate of change changed. Interesting. All right, now it wants us to do like the rest. It wants us to do it from 0.5 to 1.125. You know what? I'm getting tired of writing change in y over change in x. They created a Greek symbol that means change in, right? So if you ever see delta y, that means a change in y. Or a change in x can be written as delta x. So this little triangle in Greek means change, right? So I'm looking over here, and I'm here at the beginning, and I've dropped to here. So if I connect my secant line, I'm seeing that my average rate of change is going to be negative because I'm losing height. So how much did my y change? So using a sanity check, it looks like it drops all the way from 6 to 0, and it looks like something slightly over half a second. Let's calculate it to get a very accurate answer. Notice I am setting myself up for success. I know there's going to be 4 numbers that I'm going to be comparing, right? On the one hand, I'm going to have 1.125, and I'm going to have 0.50. I'm going to have 0 here, and I'm going to have my original height of 6 here. Okay? So 0 minus 6, that's negative 6 feet. And then over here, I'm going to do 1.125 minus 0.5. That is 0.625 seconds. And I myself am going to need a calculator for this one. Putting it into the calculator, I see it's negative 9.6. So let us write that down here with its units. Okay, so we've been calculating average rate of change. Why? Why is it important? Well, it kind of tells you what's going on in the problem here. At first, my projectile is going up, and it covers 3 feet in a quarter second, and then it only covers 1 foot. And when I calculated the rate of change here, my original rate was 12, and my new rate is 4. This is showing me that it's slowing down, right? And then over here, when I get a negative answer, that doesn't mean that it's slowing down. It means that it's going down, right? So there is something here with these numbers and what it means. So what does average rate of change mean in this scenario? Well, looking at the units, I'm noticing that I'm going to have feet per second. That is units for speed. But also, I got to be careful because speed can't be negative. I've never heard of someone say, oh, I went negative 20 miles per hour. They never told that to a police officer when they get pulled over. Oh, I was going negative 30 miles per hour. So what does it mean to have a negative in front of something that means speed? Well, you'll learn in physics class that speed's not exactly the correct answer. It's called velocity. And velocity is how fast you're going, and if you have a negative, it just means you're going in the opposite direction. So in this example, my projectile goes up. It goes up fast. It slows down. And then it goes down really fast. So that is what this problem is all about.